Hey guys, back at work on the Admiral. I wanted to update you on a few things. One, I ordered a potential replacement for the width coil. WC27, I think. No idea if it's going to work, but I figure it's worth a shot. So in the last installment, I discovered that the width coil was bad. That's what this tangled mess is here. I borrowed one from another working set, the same Admiral part number. Still had trouble, so I ended up replacing the horizontal ringing coil, and that did the trick. But there's still drama with the picture tube. There's been arcing and flashing and glow inside the neck. It doesn't really focus too well, but it is kind of a bright picture. So I wanted to get it back up on my tester to see what the heck might be going on. So right now I just have it warming up. Now let's see about going through some of the tests. So I'm doing the shorts test now, no problem. Doing a cutoff test, and then emissions, and what do you know? We've got serious purple glowage down the barrel. That means it's gassy, I'm afraid. Earlier it seemed to just kind of be phosphorescing on the glass, which some power tubes will do. It doesn't necessarily mean anything bad. It's just stray electrons in the glass causing it to fluoresce. Purple glow in the heart of it, that means you got some gas in there. So that's basically that. I'm not going to be able to do anything with it. We'll keep running it, but I suspect during the course of this project it's going to die. So another thing I want to talk about, seems to be a lot of confusion about the other coil, the width coil, this guy. So, a few things. It is not a resonant circuit. It is not a tuned circuit. There's no capacitor across it. Take a step back a little bit. So, it's called a width coil. It's not called an AGC coupling coil or a keying coil or anything like that. So, pretty much every early TV has a width adjustment, and the way they do that is by tweaking the flyback. So flyback, it's transformer, and this is the standard setup. There are variations, but this is a pretty common one. So this side is an autoformer, essentially. So ignore that side for the moment, just this side. So we've got a horizontal output tube, and we've got power coming in, so it goes through to the plate. And this is an iron core, a whole bunch of windings around it. Well, there's a whole bunch of more windings on the upper section. And that is what creates your high voltage that drives the set. So this is one continuous coil, but you energize part of it, and you can essentially think of this as the primary and this is the secondary. This has more windings than this. You get more voltage out. But they want to do some more with this. So, hey, we need to rectify that. We need a high voltage rectifier tube. The early high voltage rectifier tubes, the cathode and the filament are one and the same. So you can't power it from, like with the other tubes, because you got high voltage on this. So we could use a separate filament transformer that's got high voltage insulation on the secondary just for that tube. And some really early pre-war sets did that. But in this case, hey, we've already got this energized iron core here. Let's throw a couple loops of wire around it. Throw a resistor in series to limit the current, and power the filament from that. So that takes care of that winding. Then we've got this. What is this about? Well, one other thing we need to do is deflect that electron beam across the picture tube horizontally. So just as there's a vertical output transformer over here to power the vertical windings on the yoke, we need to power the horizontal windings on the yoke. And that's what that is for. And that goes over to that. So this is doing three things so far. Stepping up to create high voltage, powering the filament of the high voltage rectifier, and serving as a transformer, an output transformer for the horizontal yoke winding. Now that's got to work really, really well. It's got to be really linear, and it's got to be very precise. No ringing, and it's got to snap back quickly. Nice sawtooth action on it. So one thing that helps with that is the damper tube. And something else that helps is this linearity coil. And the drive control. All of these are fine-tuned adjustments to get this flyback working at peak efficiency and with a really linear travel on the horizontal yoke winding. One more thing we want to do is control the width of that horizontal sweep, so it goes from one side of the screen to the other. We don't get the image chopped off, and we don't have a lot of blank space on either side. So, well, one way to do that is you tune sort of the performance of that winding that couples to the yoke. So that's what I got a tap on here that goes over to the width control. So this width, the primary of this width control is actually in parallel with the suction of a winding on the flyback. So it's an inductor in parallel with an inductor. That tunable slug in here has nothing to do with coupling the primary to the secondary or to tune it or to peak it or anything like that. In fact, completely forget about the secondary. This is primary function is to tune the coupling to the horizontal deflection yoke. Most sets, or especially the sets earlier than this, the width control, width coil, it's just a coil. It looks just like one of these. It's just, there is no secondary. It's just a coil wire. Somewhere along the way, some engineer had a bright idea. Hey, we can improve the performance of the AGC circuit if we only look at the amplitude of the horizontal pulse signal, horizontal sync signal, because that should be a constant amplitude. Well, one way to do that is with this circuit with the AGC tube up here, and we need to pick off that signal. They also call it a keyed AGC, is a term they use a little bit later. So sometimes you'll see this with coil with key winding or gate winding or AGC winding. So they could have done this in a bunch of ways. They could have wrapped some more wire around the flyback and just used that. But they already had a with coil in these sets, so they just threw some wire around it to create a secondary to get a pulse, because they need, in this configuration, where that's going right to the plate of this tube, they need about a 200 volt pulse. That's why there's so many turns on the secondary compared to the primary. They needed a large pulse. Also using a dedicated kind of secondary this, and maybe the winding pattern has something to do with this, but they want to shape that too. Well, it's also done with these resistors and capacitors. They want a nice, well-defined pulse coming out of this thing. So the comments and thoughts about the winding pattern being critical, or finding a resonance, or the Q factor, or it being a tuned circuit, nothing to do with that. It's basically a step-up transformer. And they're just grabbing a signal and stepping up the amplitude to power another tube. So I got one comment, hey, take a standard width coil that just has the one winding and wrap a bunch of wire around it. That would probably work if I got the number of turns right. I think that winding pattern, which is done to reduce the capacitance between the windings and so on, it's just because that's the kind of coil winding machines they had at the factory. I really do. I don't think this pattern is necessary at all for that AGC winding on the width coil. A potential width control replacement has arrived. WC27. Primary reason I got this was it was readily available on eBay with free shipping, and I know the seller by reputation anyways. Will this work? Don't know. As I've said, there is no officially stated replacement for this with coil, and this one was designed, I guess, for Silvertone, Stuart Warner. That's what it says on the sheet, but on the back they list a number of other sets, most of which I've never heard of. Now, they may very well, like Shaw, probably didn't make their own TVs, so although it says 630 type, now it's interesting. So if they mean the RCA 630, but that was used in a whole bunch of sets, and you'd think if it was compatible with an RCA 630 TS, they would list RCA 630 TS on this list, and they do not. So I'm not sure what a 630 type means. But anyway, my point being that some of these are smaller companies, and the chassis in them, they might have purchased from Stuart Warner, or like Silvertone didn't make their own chassis either. That would be Sears. So these could all basically be the same chassis, just in a bunch of different brand names. Cal Best, I'm sure, did not make their own chassis. Those were probably department store chains or something like that that had sets created with their name on the front of them. Anywho, also notice that in here they call it an AGC winding, but on the box it says keyer winding. Again, that's another term for this arrangement, is keyed AGC, meaning it's keyed off of the sync pulse. So what have we got to lose? Absolutely nothing. Here's a look at it. This seems to have a smaller ratio of primary to secondary. In other words, there are nowhere near as many turns, and the wire is thicker. So it does concern me a little bit. Also, AGC winding, it says at 1 ohm. Now this is tapped, so I think that's what that at 1 ohm means. Let's see, yes, there are 3 wires coming off of the AGC. Because I got to imagine the resistance from one end to the other of the AGC's got to be more than 1 ohm, especially if the primary is 28 ohms, and it's got maybe the same wire, very similar gauge wire, but certainly less turns. So the primary is 28 ohms, secondary's got to be at least. But that does concern me because we need a pretty healthy ratio of primary to secondary. That's what the original had. The primary was thicker wire and not that many turns, and the secondary was fine wire and a whole lot of turns. Because if we don't have that large ratio, we're not going to get that 200 volt pulse we need, so this may not work. So one thought is that if the primary is compatible enough with the flyback, and I need more turns on the secondary, I can certainly just start winding more turns on this thing. And we can kind of see from the end view here, it does use some type of universal or basket weave pattern. It's not just straight from one end to the other and back and forth. Again, do not know that that matters. It could just be that's just the type of coil winding machines they have in the factory, and that's how they wind all the coils. This certainly does not run at high frequency. This thing's only running at a little less than 16 kilohertz, so there's no RF involved here. Alright, enough blabbing. Well, how do we find out if it works? By installing it. Now, the other issue with this is the original had some long wires coming out of it, and it didn't have lugs quite like this. So the 2 shorter wires were for the primary. And on this, the primary would be the lugs. Yes. And then these fine wires are for the AGC, and the fine wire for the AGC is to go all the way up here. So I need to attach some wires to this before I can even think about using it. At least it's the right type to fit through the opening on the chassis. It's the right diameter. It'll just fit right in and click. So we got that going for us. If this doesn't work, I know of 3 other possibilities I can try, and I got sources for all of them. And of course I could try rewinding it. Okay, I got the with coil tacked in, and I actually put it the opposite of what they say. Which doesn't make sense to me. They say the primary winding should be the 28 ohm, and the AGC is the 1 ohm. That's the exact opposite of the original, which had low resistance on the primary, and also the lower resistance winding is the inner winding. So I kind of think they got this backwards. And whether they do or not, I hooked it up the way that made the most sense to me and is most like the coil that I'm trying to replace. So it'll be somewhat of a minor miracle, I think, if it works, but, you know, hopefully it'll at least be interesting. So here we go. It also makes sense too because the two enameled leads are just like the two enameled leads on the one I replaced that are the primary that go right to the flyback. Well, that's certainly promising looking. How about that? Well, I'll have to fire up the scope to know for sure that we got AGC pulses, but we wouldn't have an image of the AGC voltage wasn't at least somewhat in the right range. So hey, how about that? How about that? Now, as far as it functioning as a with control, well, even if it doesn't work quite right, there are other ways to tweak the width. I also don't know what the original mask looks like on this set. I suspect it's a double D. Early sets had a rectangular opening because the broadcast image is rectangular. Right now we are losing the corners. But it was a trade-off, especially for salespeople, to maximize the the viewable square inch. So the earlier sets were all rectangular, something like that. I mean, they had a round picture tube, but they put a rectangular mask in front of it because to match the broadcast image, so the viewers could see the entire image. But then some salespeople got involved and like, well, we want to say we have more square inches, but use the same picture tube. So how do you do that? Well, you still crop off the top and bottom, but you make it go full width. So they call it double D because it looks like a D going in either direction, split down the middle. But if you were, say, watching a sporting event and there was a score down in the corner, you don't get to see it. So not the greatest trade-off in some cases. And then there's, you know, porthole and other similar porthole sets where they just use the whole friggin' screen, and then you're really losing a lot of the image, but you're definitely getting the most square inches possible. All right, I will get the scope fired up and hook it up to the plate on the 6AU6, and we're supposed to have a 200 volt pulse. Okay, got the scope hooked up to the plate of the 6AU6 AGC tube, and here's what it looks like, and it does look a bit different than it did than it's supposed to. It is higher amplitude, 150 volts per division, so 1, 2, 3, 4, 5, so we're like 300 volts, and it's not quite as sharply defined. On the other hand, it's working. So one thing I'm curious about is, I know some of you, when you were given suggestions about how to replace this coil and whatnot, and I was trying to explain that when you adjust the slug on this, it's to, so right now I'm getting this tool out, trying to adjust the slug, it's to affect the width of the image, not the coupling between primary and secondary. So when I change this, so I'm rotating it quite a bit now, it's not changing. That's how it's supposed to work. The AGC is just kind of, it's an added bonus to this coil. It's acting like it's just a coupling it's a step-up transformer. It's not a resonant circuit. However, when I adjust the slug, the width of the screen should change, but it's a very minute change. From one extreme to the other, it may change the screen width like 2%. I see all the time people posting online, the width control doesn't work. It's not going to change it like a couple inches. That's not how it's designed. So I'm cranking and cranking. I've almost gone through the whole cycle now. Without a test pattern up, I don't think I'll even be able to tell if it is changing the width at all. Not with actively moving images. And it's potentially there is too much width. Certainly, but that's a better situation than having not enough. But there are tricks you can do with that. You can tweak the component values on the damper tube, linearity coil, and there's also that drive control, this trimmer control here, which kind of serves as a coarse linear adjustment. You also want to mix you can help have the flyback run as efficiently as possible because it reduces the drive to the horizontal output tube and the current going through the flyback, but it also can affect the width. In this case, again, it's hard to tell what it's doing without a test pattern up. So, I'll take it. Also, rather curiously, the picture tube has calmed down. I don't see any. Well, no, there is a bit of. It's hard to see with the naked eye, but I can see through the camera viewfinder. There is some blue glowing. But that's that phosphorescence kind of on the glass, not the purple glow down the center like we saw with the CRT tester. And no arcing. It's weird. Now, it is possible if there's some getter material left, that while the set's running, and if a little bit of air leaked in, the getter is scrubbing it out. I can see the glow better now with the subdued lighting, but that is not. It doesn't look like nitrogen gas that got inside the vacuum and corrupted it. It looks more like stray electrons hitting the glass. Weird. I suppose it's also vaguely possible it's backglow, because the image on the reverse side of the CRT is actually brighter than the front side. Just think about it this way. There's a phosphor deposit on this glass. Let's just say, for the sake of argument, it's like an inch thick. It's not, but let's just say it's an inch thick. The electrons are hitting the back side of it, causing the atoms to do their thing and glow. It's got to then travel through that inch of material and then the glass for you to see it. On the reverse side, you're seeing the electrons hit the surface of the phosphor, and it actually glows a little bit brighter. So, in other words, that light can be coming back down through the neck of the CRT, and that could be some of the light we see. I don't know. So the owner of the set has been watching the videos, and I sent him an email a little while ago telling him what the situation is, and I'll leave it up to him what he wants to do about a picture tube. I've got a potential lead on 1 or 2 replacements. I don't know how much they want for them. I expect they won't be cheap. I'm loath to give up. I've got a couple. We'll see, that's the thing. I have a bunch of 12-inch sets left to restore. I was about to say I've got spares, but I don't know if the ones that are in those sets are any good. So I might not have enough as it is from the sets that I want to restore. So, I mean, basically I'd say keep using this until it stops working. Right now it looks like it's working great. So, what's next? What's next? Well, one, I will tell the owner the good news that the width coil, in spite of the amplitude being a little bit larger than it should be, seems to be working alright. I can double check the specs on a 6AU 6 tube and make sure I'm not exceeding the maximum plate voltage. If I am, I could always throw a resistor divider in there and knock the voltage down a little. And more extreme, I guess I could unwind some turns from the secondary, but no, I'm not going to do that. And then I want to go through and replace a few parts. I never did go through and do any of the audio components up in here. And then it'll be alignment time, which I know some of you are interested in seeing. I was just editing down some raw footage, and I realized that I wasn't really explaining this AGC quite right. That pulse that comes out of the flyback via the AGC winding on that width coil goes to the plate of a 6AU 6 tube, and that is not sampled to create the AGC voltage. That controls when you look at the incoming signal to create the AGC voltage. So assuming your incoming signal is synchronized to the local horizontal oscillator, the pulse from the flyback should be occurring at the same time as the incoming horizontal sync pulse. So the pulse out of this width coil is acting like a sample and hold. It's telling the TV when to sample the incoming signal. It then holds it for the duration of the scan line until the next sync pulse occurs, in which case it samples it again. I hope that makes some sense. Alright, that is going to be it for now. I am going to go through and replace a few components, and next installment should be the alignment.